Hi students, this is Mr. Yao. Today we are going to talk about 6.5, where we will learn something called a geometric sequence, but we will still learn about recursive formula. Let's review what we have learned real quick first. What was the last type of sequence we have learned? It was called arithmetic sequence. Arithmetic sequence. Next, what kind of pattern does it follow? We were actually adding or subtracting the same number to actually get the arithmetic sequence. And next, what kind of formulas did we learn? We actually learned two different kinds. The first kind is called recursive, which the formula itself is easy but takes longer time to get to a specific term. And the other kind of formula we learned is called an explicit formula, which can get us the direct term real quick. Today's lesson is still going to be about recursive formula. In this lesson, the definition of recursive formula does not change, which means it still needs two parts. For the first term and a formula that connects consecutive terms, which means an and a sub n minus 1. These are the two consecutive terms that we typically use in a sequence formula. But we will explore a different type of sequence, and that is called geometric sequence. The second specific type of sequence we will learn is called a geometric sequence. In a geometric sequence, we're not adding or subtracting the same number anymore. Instead, we are multiplying the same number this time to get the next term. And since we're not adding or subtracting, it's not going to be a difference anymore. It's actually going to be a ratio, because multiplication and division are kind of the same, and ratio is typically formed by division, and we can also use division to find the ratio. And the ratio is between every pair of terms, and they're the same. That's why we call it a common ratio. And since the common ratio is not common difference, we can't use the letter D anymore. We're going to this time use letter R. The recursive formula for geometric sequence is right there. We still need to list the first term. That's always going to be the same. And as you may notice, the first part of the second equation, the first part of the second formula is exactly the same. It's a sub n equals a sub n minus 1. For the arithmetic sequence, it's actually a sub n equals a sub n minus 1 plus d. That's what we have learned before. And for this lesson, the only change is instead of adding d, we're going to multiply by an r. Now let's have a look at some examples. Example 1 and 2. I did make a typo, so please change the d into r, since we're talking about common ratio. If these information are given, the recursive formula is very easy to write. A sub 1 is 3. Remember, even though the question gave that to you already, you still need to write it because it's part of the formula. You need the first term to find the next terms. Next, the second part, a sub n equals a sub n minus 1 and times 2. And please make sure you actually write the multiplication sign, because a lot of you actually write your sub n minus 1 pretty big. Then the whole thing just becomes n minus 1. And if you actually don't write the multiplication sign, then it's just a 2 there. That becomes n minus 12, which is not exactly right. So please actually write the dot to indicate multiplication. Next, example 2. B sub 1 is 4. Still need to list the first term. Then it's b sub n equals b sub n minus 1 times. Ever since the beginning of school year, I have been saying whenever you multiply by a negative number, please put that inside parentheses. So I'm going to put the negative 2 inside parentheses, and right before it, again, make sure to write the multiplication sign. That's example 2. Next, example 3 and 4. We still need to list our first term, which is 54, right here. Next, let's quickly talk about the formula again real quick. The second part of the formula is a sub n equals a sub n minus 1 times r. If you actually want to find the r, it's just like solving an equation. You need to get rid of the a sub n minus 1 by dividing both sides by a sub n minus 1. So that is gone. And you only have r left on the right side. And if you look at that, that actually is the next term divided by the previous term. So that means whenever you want to find the actual ratio, you always use the next term divided by previous. The next term divided by previous. So it's either 18 over 54, or 6 over 18, or 2 over 6. That is going to give you the r, which is 1/3. Now let's write the final formula. Again, a sub 1 equals 54, part of the formula. Then a sub n equals a sub n minus 1 times 1/3. That is the whole formula for example 3. Example 4, same idea. Next term divided by previous, next term divided by previous, next term divided by previous. So R is negative 36 over 72, or 18 over negative 36, or negative 9 over 18. All of them are going to give you negative 1/2, which is why here's my formula. A sub 1 equals 72, and A sub n equals A sub n minus 1 times, make sure you write the dot again, and since we have a negative number, put it inside parentheses. That's my example 4. Next, example 5. Use a recursive formula, list the first 4 terms and find A sub 9. This is exactly the same as what we have learned in 6.2, where we actually did this for the arithmetic sequence. So let's have a look. A sub 1 is already given, so I'm going to start with A sub, A sub 1 is given. I'm going to do A sub 2. A sub 2 equals A sub 1 times negative 2. By this time, you really should be able to understand that A sub n and A sub n minus 1, they simply mean 2 consecutive terms. This is the latter one, and this is the previous one. So whenever I start with, like, say, A sub 2, you just need to know the right side. That means the previous term, which is A sub 1. It's always the one before it. And my A sub 1 is actually a 10. So 10 times negative 2, that equals to negative 20. And since we're writing this, I'm going to mention something that you guys have done on the quiz. Something you do need to understand is this A sub 1 is actually one thing. A is not a variable. It is just a letter we use to represent a whole sequence. Like A sub n represents the whole sequence, or any term inside the sequence. So when we do A sub 1, it's not like, oh, I'm just going to replace the A with, like, say, 23, and then I still do the 2 minus 1 as a subscript. That's not how it works. If you want to replace A sub 1, you have to replace it all together with whatever number it is. Like right here is a 10. Next, I'm going to do A sub 3. That's going to be A sub 2 times negative 2. My A sub 2, I just found it, is negative 20 times negative 2. Negative sign become positive. So A sub 3 is 40. A sub 4, you just need to use the previous term, which is 40 times negative 2, because that's our common ratio. That's going to be negative 80. We can keep on going. A sub 5 multiplied by another negative 2. That is going to be 160. A sub 6 multiplied by another negative 2. That is negative 320. A sub 7 is going to be 640. A sub 8 is going to be negative 1,280. And lastly, A sub 9 is going to be 2,560. Now we have our A sub 9. Of course, this is a pretty redundant way to find that specific term. We will learn how to find the terms directly after you get back from the break. Next, example 6. So we look at example 5 and example 6. In example 5, you are given A sub 1 and you are being asked. You get given A sub 1, you're being asked to find A sub 9, which means you're going forward, you're moving forward to find the latter terms. Instead, for example 6, you are actually given a latter term and you're trying to go backwards to find A sub 1, which means you can't use the recursive formula directly. So if you are going backwards, that basically means you are dividing by a negative 3. But since the formula is actually multiplication, we're going to keep multiplication, which means that is the same as multiplying by a negative 1/3, which is also called the reciprocal, when you flip the fraction. So let's go ahead, find A sub 6 first. You're going to need A sub 7 this time, which is 81, then times negative 1/3. That is going to give you negative 27. A sub 5 is going to depend on A sub 6, so it's going to be negative 27 times negative 1/3. Both negative sign become positive, so that is going to be a 9. A sub 4, keep going, multiply it by a negative 1/3. That should give you a negative 3. A sub, not 5, A sub 2, A sub 3 is going to be negative 3 times negative 1/3. Negative sign become positive. That's going to be a positive 1. A sub 2 is going to be 1 times negative 1/3, so it's negative 1/3. And lastly, A sub 1 is going to be negative 1/3 times negative 1/3. That is going to be 1 over a positive 9. And that is example 6. And that's everything for 6.5. Thank you.